Okay, thank you. So we are starting with stress. Well, what is the definition of stress? It is the applied force divided by the resisting area. That is definition of stress. And numerically term pressure, which is also force by area. Okay. So what is the difference between stress and pressure? Both is force by area. Only both of them will be Newton per square meter or kilonewton per square meter or like that. Okay. Force by area, that unit. Externally, there will be resistance in the structural system, and that resistance leads to stress. And pressure is the externally applied force. So stress is related to resistance, and pressure is the external one. So they are both numerically same. Now, what are the types of stresses? There are two broad classification of stress. One is normal stress, one is combined stress. When it is normal stress, it can be tensile, it can be compressive. I think we understand these terms, right? When it is combined, these tensile compressive forces, they are combining in different ways and giving rise to shear stress or torsional stresses. Now, when it is tensile stress, just as the name says, there will be tensions developed in the structural member. There will be opposite pulls. Okay, we have one structural member. There shall be opposite pull in the structural member. So then there will be tension in the structural member, as simple as that. So that is tensile stress. Now the force divided by area, that will be the value of that stress. What will happen in case of compressive stress? Just the opposite. We have the same structural member. Now the forces are acting towards each other. It's trying to decrease the volume of the structural member. So again, the stress value will be forced by area, but the nature of the stress is different. The earlier was one tensile, the later one is compressive. Then there can be another type which comes under the combined stress. This is shear stress. Now, what will happen in shear stress? Forces parallel to the area resisting the force causing shearing stress. They are also known as tangential stress. We have a body, we have a structural member. When there is a resistance like this, okay, we okay, we have some structural member. There is some external load on the member, right? And there is this type of support is there. This support is also resisting this external force in the opposite direction, right? So one force is acting this way, another force is acting this way, like this. They are trying to balance each other, but there are two forces which are acting opposite to each other, and they are trying to cause shearing in that section. So this is basically shear stress. Then torsional stress. So torsional stress will, what it will do, it will develop a twisting moment. Okay. We have one structural member. So if there is one force trying to rotate it this way, another force trying to rotate it on the other way, then there shall be twisting moment or torsional stresses induced in the structural member. This way we can see here in this member, this is tensile. We have one structural member. Forces are pulling it away from each other, and this at this region, what is happening? The fibers of the material, it may be concrete, it may be steel, whatever material this beam is composed of, it is tearing apart. It's being separated by this tensile force. And what type of stress is developed? tensile stress because the force is tensile force. Here in this case, forces are acting opposite to the case of tensile. It is now acting to compress the volume and it stresses to each other, but exactly twisting like this. One force is in this way, trying to rotate it this way, another is trying to rotate it on the other way. The torque, we have a twisting moment, and stress that is resultant out of this torque and moment will be called torsional stress. Now, the next definition is what is strain. When a body is subjected to some external force, there is some change in the dimension of the body. Okay, very simple. If it is subjected to compressive stress, the stress is trying to reduce its volume. If it is able to reduce its volume by some length, like this, say for example, this is the change, right? Say for example, delta L, change in the length. Now, this delta L divided by the original length, that is strain. The ratio of change in dimension of the body to the original dimension, this will be strain. Strain is a dimensionless quantity. We have to remember this because why it is delta L, that is a change in length, that is also going to be in meter, centimeter, or millimeter, and total length will also be either centimeter, millimeter, or meter, something like that. So millimeter by millimeter or centimeter by centimeter, there shall be no of unit of stress. We have to remember it is Newton per millimeter square per meter square. Okay, Pascal, kilopascal, megapascal, like this. What is Pascal? Pascal is Newton per meter square. So this way there are units for stress, but there are no unit for strain. Strain is a dimensionless quantity. Then what are different types of strain? There is tensile strain. Tensile strain will be caused by tension, that is tensile stress. Compression strain, that is compression stress will be caused by compressive force, right? Volumetric strain, when the entire volume is changing and when there is shear deformation. Okay. When there is shear deformation like this, we have shear force acting on it. The volume is remaining same, the length it may remain same, but there is a deformation like this, shear deformation. Now, these are definition. Tensile strain will be increase in length because it is tension. So the tension or the tensile stress is trying to increase the length of the structural member. Very simple. The definition, by definition, the numerical expression will be what? Increase in length divided by original length. Compression length, therefore decrease in length divided by original length. In volumetric strain, we consider the entire volume of the member, right? Here in this case, we are just concerned with the what increase in the length. If it increases in the length, this sideways it may reduce as well, but we are not considering that in this case. Concerned with the increase in the length. But in volumetric strain, we are considering the entire volume. Okay. What is the change in volume divided by original volume? So once again, just very simple. It is, if it is compressive strain, it will be acting like this. Okay, it will bulk and at some point it may fail. If it is tension, it will be acting like this. The section will become thinner as it will be elongated, right? That way. This is bending. This is torsion, twisting is acting on it, and this is shearing, two parallel forces acting in the opposite direction. That way. Once again, volumetric strain we have already seen. So if it is volumetric strain, what will happen? Forces are acting in all direction. It is trying to reduce or increase the volume. Okay, in this case, compressive forces are acting from each direction, trying to reduce the volume of these object or material. So what happened? A volume changes by delta V. Okay, in all sides, the volume reduced by delta V. So delta V is the change in the total volume divided by original volume. That is our volumetric strain. Then there are some sign conventions. Okay, these are base generally followed. Tensile strains are generally positive. Is the length. Compressive strains are negative. Okay, they will be producing decrease in length. Then the next is, okay, we will discuss next and stress strain curve next time. Okay, so just once again go back and see different type of stress and strain, how twisting and shear, what is twist, what is shear force. I don't know if you have learned this term, shear force, bending moment. I think you should have. So let me know if you have solved numericals of shear force diagram. Okay, that you see once if you have back and refresh your memory, and then we will again discuss about this, stress strain curve of different materials. Okay, next class. Okay, uh, and there is one video in the Google Classroom. Let's see the video.